All right, I just can't leave the code in the state that it was in. So I've run now SPIRiT that we checked out, and it gets a good image out. So there's clearly some difference between the new SPIRiT and the old that's causing this issue. So we're going to use file merge to see what the differences are. So this is all fine W, but we checked that that gives the exact same answer. Before we were padding data inside, and now we're doing it outside. That's the issue? Let's see what happens if we comment out that line of code. Oh, it actually commented out that line of code. I should be able to pad this and it should be fine, and I'm perturbed that it's not. That padding was doing it. Now recall, like, circular convolution is doing padding inside. So somehow padding and then flipping is giving me a terrible answer, but flipping and then padding is doing fine. The results should be the same. Never be able to do that. Okay, so stop. Flip W is equal to flip dims W1, 2. These operations should commute, is what I'm trying to say. Okay, I'm going to pad data, flip dims, W, dims, 1, 2, M, N, and coils, W, P, F. WFP, flip pad, pad flip. I think those should be the exact same thing. And they're clearly very different. Size W2. How does this pad? So padded is going to be the size of the output. Find min index. Okay, pad data, flip, 1, 2, 3, 5 to 8. Data N, oh. Two is the origin, and 2 should be at 4, 5. Okay. Now flip pad data 1, 2, 3, 8. Flip 1, 2, 3 becomes 3, 2, 1. And then when I pad it, I didn't know that pad data with the lowercase d was a MATLAB function. That puts the 2 where I want it. Pad data 1, 2, 3. And then if I flip, I would think it would flip about that index. It flips about this point in the middle. It flips in between the 1 and the 2. Not about what I'm calling the center. function out equals flip C in bargain. I'm going to set an argument to flip dims that lets me, a binary argument that lets me flip about the FFT origin. Okay. If size of X in dimension I is even, if it's odd, just flip about the center, there's no difference. But if it's even, then we need to do a circ shift by 1 to circ shift offer the dimension argument. It does in the dimension I. Oh, this dim is equal to dims I. Is that right? We flip. Yeah. So by default, f of t origin is going to be set to true. Otherwise, I bet you there's a more efficient way to do that, but that is definitely not what we're doing today. Okay, now I believe that these will commute. Let's see if I'm right. Yeah. That was the issue, I believe. Let's see if we can get a reasonable image out. This is very slow. Very slow. Can I refresh this? Recompare. I've got this pad data now. Oh boy. It's taking quite a long time. Where is it? It's still in Spirit New. I've done a lot of code. Spirit. Wow. That is still terrible. Now some things are starting to make sense. Because there was this issue with flipping and padding or padding and flipping, LSQR may have been, or whatever, may have been taken much longer. Just more iterations. And so that was altering the amount of time it was taking to do, like, to complete things. That was messing with the results of our profiling is what I'm trying to say. taking a very long time. We're not even doing spirit regularization right now. We're just doing spirit. That is a terrible result. If I compare again, this is commented out. The only difference between spirit and spirit new seems to be calculating find W. Okay. We're going to comment that out. We're going to add this in. We're going to run it again. We're not using find W. All of this code is the same. This is the only difference here is the comment. The only difference here is a comment. These two lines are commented. The only difference is a comment. The verbose I just added is meaningless. This find W function doesn't get used. The verbose. Okay, so this should be the same result. It's taking a very long time. It indicates to me that it's not. It's not going to be the same result. Boy, oh boy, this is really not going as I had planned. I thought we were going to do the support today. This should give the same result. And if it doesn't, I'm just going to copy spirit. We're just going to modify spirit one line at a time to see what happens. Not spirit new, but spirit. That is still a terrible result. Okay. Just to be sure, how does spirit do? Check out what's going on in handmade.network. People are doing really good stuff. Last post I made. And this is still running. If recon spirit isn't working, which I thought we just checked. I just checked it. What on earth? Just to be sure. I have an idea. I think it's flip dims. Right? Because in circular convolution, well, flip dims by default now sets the FFT origin to true. But circular convolution is using it, and it's doing the shift. So now I think we could get rid of this shift. This flip is about the origin that we're intending now, as is this flip. Check passes. Yeah, now the circ shift is embedded in flip dims. Okay. Let's get this running. So flip dims flips differently than just flip, which is weird. That's the good image. So that was the issue. Now if I do recon spirit new, and I'm just going to do it all, well, we'll start with just this. We're going to comment out that code. We're going to comment in find W. It took 60 seconds before. Good image out. Very good. We can delete these lines of code from circular convolution because now the circular shift is embedded in flip dims. It's not subsequent, happens in the same line. Surely that'll make things better. Okay. So that worked out well. So we could delete these lines of code and just use, we could delete these lines of code and just use find W. Okay. Now I'm going to do all of the optimizations. That still took 55 seconds. Did it again. Taking a long time. This indicates that, oh, got a good result out, 51 seconds. Let's run it again. Will it get, now that we've primed it, will it reduce its runtime? And now we're going to try, afterwards we're going to move this flip here. $50 seconds, okay. Did we still get a good result out? Yes, we did. Coming back over here, now we can delete these lines of code. Flip dims, W dims 1, 2. Call this flip W. Flip W. Flip W. C. How long does that take? Still getting a good image out. That's good to know. It takes 40 seconds. That's also good. We're going to overwrite SPIRiT. We're going to delete SPIRiT new. Okay. We're going to try profiling it to see where everything is, where all the time is being spent. And we're even going to close the file so that we can't possibly change it while the profiler is running. So it took 42 seconds. 36 seconds in apply W. The circular convolution is taking the most of the time. This is taking 6 seconds, just flipping the dimensions now. Inside of flip dims, this circ shift is taking a lot of time. I don't have any good ideas of what to do with that yet. So let's make sure these improvements are in here. If I take out SW and make that S image, does that still run well? Because I can't find SW anymore, and I don't know where it's being called, and I forget why we created it, and I think it should still work. That looks pretty good to me. And now, if I replace this apply W with the other, you get a bug. MN. M. There's that image we're making. Okay. So I believe we've done some minor amount of optimization that makes the code slightly faster. We're going to check stuff in. Okay. Now, let's use the support. I'm changing the order of lambda and gamma because I like things in alphabetical order by default. FSS is now going to become FSP. Why do I say that? Because temp image is equal to 0 is S image. If NRIN, if numL of support is greater than 0, then in is temp image support equals 1 is going to equal in. And then, so we'll call this P in. Actually, we'll call this P transpose in. So here, P is the matrix that takes the image and isolates the the pixels just inside the support and creates a column vector of those pixels. PTN. SPTN is equal to otherwise SPTN. Okay. What about the adjoint? Well, if the null of the support is greater than 0 now, out is equal to out, support equal 1. And I think that does it. Let's do checks. So that should be called P transpose. Apply FSP transpose. Ooh, but now that's different, isn't it? We actually need an apply FS, so forget everything I just said, everything I just did. Okay. Much cleaner way to do this. Let's do checks. Support is invalid. Is numeric. Why is it invalid? Is it logical? logical. Okay. And we'll get rid of the is numeric because it could be numeric or logical. I guess I could do this. Why not? Okay. Passes. Does A pass? No, crashes. Different number of elements. Oh, I did this wrong. Which makes me wonder how P passed. Still an adjunct, but I would have thought the input was wrong. So just to be sure, P takes an image and outputs, yeah, okay. Now that crashes, why? Right, okay. So that wasn't the issue. Then why is A failing? Because this should have been no transps. Oh wait, no, that is transp. In it's 256 by 256. The transpose should just take out very, very confused. Okay, P, the transpose should fill it in. Right. The transpose should fill it in. The issue is with A. Check adjoint of A. passes. Now we should be using the support, except that it crashes. Why did it crash? Because my initial guess now is the wrong size. Image 0. Where does S image get used? Okay, at least gets used there, so let's keep it. We're going to have to pass image 0 in. Because we inside these functions, minimization over the sphere or Tikhonov, we don't know what size they should be. Okay. We're going to have to just take and support out of do checks. It's the first time we see support. Similarly, this may not necessarily output anything of size S image anymore. These things might just find a vector of values that go inside the support. We could pass the support into recon model based. If we go down here to Tikhonov, apply A. What does apply A do? This is how much I'm struggling with even the small amount of code. Apply A does FSP and WM minus I. should we call it FSPT? I need to leave pretty soon. Just make this off. We don't strictly need this, and it leads to an additional comparison. If we're down here at Tikhonov, I don't like short deadlines, and I need to leave soon. We actually need to apply M. Let's check this adjoint. Just to be sure, apply M does what I think it does, right? It does. Okay. Because we need the same input as the support. And support. passes. That's good news. The reason I did that is because I want to get rid of model-based recon. We're not going to have time to test this now. So this is a superset of model-based recon. Basically, recon spirit regularization, if this works, just became model-based recon. Let's see if that runs. It's running. Okay. So what just happened? Now we're taking advantage of the fact that we know there are zeros here. And so this image just got a little bit better. We are now accounting for the non-rectangular field of view. And with that, we're going to check stuff in. Now using the support. Okay, took a lot longer than I expected. The optimization didn't work as well as I expected. What are you going to do? We're done. I'll see you guys next time.